Welcome today. It's Mahmoud Miari. We're going to go through a very important topic. It's the cloud computing services. Before starting with the cloud computing services, I would request from you to be having like some awareness about cloud computing basic concepts and if you are good in networking and some server techniques, it will be like helpful for you and beneficial for you to understand this video. So before starting, allow me to introduce myself. My name is Mahmoud Miali. I'm working as a head of operation for ICT sector more than 15 years. It's around like 17 years. Uh, I'm handling like network projects and courses, cybersecurity, cloud computing, big data, and many other sources. I've been in the coach sector since more than 7 years. I developed like some good like thousands of engineers to be practiced in networking and the cloud services. So our expectation from this video and the small course, it will be like I will refresh your memory about some cloud computing concepts. I will mention some vendors of cloud computing and will be emphasizing on cloud compute services and what are the services around cloud computing. So we'll go through introduction of cloud computing, cloud compute services like such as the main services, compute services, network services, and storage services. So let's talk about why cloud computing came. Actually, my aim is always to, before explaining, to know why it came and when it came. So previously, the traditional infrastructure of IT infrastructure, it is normally like PCs, and these PCs connected to network switches, and having some servers and routers going you to the internet or firewall, wherever. So this is the traditional one. So when it came to the evolution of smartphones and application and social media, the scenario became a little bit sophisticated for that. So why this came? Because of the amount of data going here and there through the internet, and especially when it's come like the terminology of IoT, the Internet of Things, that you can manage anything from the internet, like for example your home. If you want to control your electricity, your AC, your CCTV cameras, all these like it's under the IoT. So it needs for networking, and it needs for also data travel on the cloud. So how the cloud came? So let's understand the conventional IT service or IT architecture and how it became like more modernized like virtualization architecture and how we came to the cloud. As I mentioned before, that the basic thing is your data center or your server room in the company. It has like some server, these servers connected to the network, and you have PCs and you are giving services to your organization. So this is the conventional IT. So whenever you need for expanding and scalability for that, you will be having some troubles and the problems. For that, we will talk about it in a while. But for scalability and expansion, so it came like the terminology of virtualization. It allows us to virtualize to create more than server from the physical server. Of course, it depends on the characteristic and the specification of your physical server, but it was like a good amount for that. As we don't know actually the expansion that I need, and it's before we are buying like a huge server and we are paying money in the traditional IT. So it became maybe we are using it or we don't use it. So here the virtualization solved this problem for us. If you have, imagine with me, if you have one big server, and this server is with this specifications 20 core processor, dual processor, and you have let's say 5 terabyte hard disk storage, and you have 128 GB of RAM. So I don't need it right now for all these services. So why I'm wasting all these? So what I can do is I can do a virtual server. So let's say that I need to create an Active Directory, and this Active Directory, mm, I can run it with 16 GB RAM, 8 core of CPU, and I need 1 terabyte hard disk. You see, and you can imagine the specs of the server is very less in compared to our main server. So I can create in a minute one virtual server, and I can dedicate it to my organization. So later on, if I need, for example, an application server for our ERP system, and this application server require for let's say 20 GB RAM, 8 core processor again, and let's say like terabyte, 2 terabyte of hard disk drive. So by that, in a minute, I can create like a virtual environment, virtual server, and I can put it on service for the user to get the benefit for that. It's amazing and it solved for us many things. But the problem is, again, for scalability, if I used all the resources from the physical server, so how can I optimize it or how can I enhance this server? So here there is a problem because in our organization right now, I have to claim that for our management. Then we need the server, and this will go for a longer process for the management for approvals, and after that to compare with the vendor with three quotations and many stuff. And let's see if the availability of the server is now, or maybe it can come for us after 3 weeks. So you can imagine the long speed that we are going for that. With the cloud, you don't have anything from this. The cloud is, uh, imagine the cloud is your organization, but it's very big, and it's on the cloud. Why is calling it the cloud? Because you don't own anything for that. You will take some virtual machine from there as per as you want, and the payment also pay as you go or pay I use as you use. So what I use is, for example, right now I can see that this server needs 8 GB RAM, 500 GB hard disk, 4 core. So I will pay for that. I will pay for my use. I think that this server is enough for me. So after that, I see that it's also too much. I want to reduce. Whenever I'm reducing the specs for that, I'm paying less. So cloud will allow me to do that. So, and this is really like a great idea, and like how can I deal with that? Moreover, also I can also access my servers whenever I want from any place that I want. Just all I want in my computer is internet connectivity, and I can do my work and do my optimization, do my installation, whatever I need, as if it's in my infrastructure, but it's on a cloud. Great. So for the conventional IT infrastructure, we have servers. This servers will install operating system, whatever it's Windows, Linux, any operating system, and it will be on the top of that the applications. Great. But with the virtual architecture, it's working with a virtualized layer. It's called hypervisor. So it will be like the physical server and the hypervisor on the top of it. And after that, we start creating our instances or our virtual server or our VM virtual machines. So we will install operating system, install application, another VM machine, and etc. For the cloud architecture, it's little bit different. It is the same, but the servers, we don't know where are these servers. We don't know. We don't care about the power, electricity, the redundancy if the power is cut down. So do I need UPS or not? This is all the cloud architecture is taking care of it. So it will be like a cloud, and in the cloud, I will create a VM. Its VM is called like ECS or EC2 in the cloud. So I will start like doing the normal thing that what I'm doing in the virtual machine, but here I don't care about the physical place of the server. Again, I don't care about the power consumption, the redundancy for that. My service should be available 100%. This is what cloud will provide for you. So this is exactly what I explained right now. I will leave it for you to read it once sharing the slides for that. So what's cloud computing? Cloud computing is model of enabling ubiquitous, convenient, on-demand network access to share a pool of configurable computing resources such as network server, storage, application, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Why this is calling like rapidly provisioned? Because in seconds you can upgrade your VM machine or your server. In seconds you can maximize your hard disk, you can maximize your RAM, you can do whatever you want. If you want to also duplicate your virtual server, you can find it over there, and in seconds you can do it. So what is the cloud computing deployment model? How we can deploy our cloud? We have three main types. Public cloud is completely the cloud infrastructure that we were explaining in a while. Private cloud is your private organization, that inside your organization you are doing your data centers and your cloud. Hybrid cloud is a mix between your organization and the cloud. For example, sometimes uh, you have significant data, you don't want to put it in the cloud. And this is a strategy and policy of your organization. Great. So if I have like, let's say, all my Active Directory, all my like sensitive files here and there, is it's in my organization, in my data center. But I care about storage. I have a storage in my data center, but I need a second backup storage in the cloud. So here the cloud can help me with that. So it's called like hybrid. Some of the features and facilities I'm using it locally in my organization, and I'm taking some services on the cloud. And these both are like my organization locally and my cloud is connected to each other in a way. Okay. So again, like for example, if I have like web application, this web application needs for traffic and many things, and from this data I need to extract data and put it, use it in my local ERP system. So I will put this website in the cloud, and after that the data, this like I can import it in my ERP system locally, and I can do it. Actually, there are many ways, but these are like two examples I give it to you to just understand the picture for that. So, how the services for cloud computing, like the model and how they are different from each other. As we said, the traditional IT, everything we have it on our stock, in our server room, in our data center. So we are care about, like as a network engineer or security engineer, we care about the network. We are managing them, the storage, the server, operating system, uh, the data, the application, everything. We are installing them, and we take care of that. But there are three main models for the cloud computing. It's called infrastructure as a service, platform as a service, software as a service. So, in the first type, infrastructure as a service, here in the in the first portion, the network, storage, server, and virtualization, the cloud provider will take care of management of them. You, as a network engineer, you don't care about the servers, you don't care about where they are located. They are down, they are up. Your VM machines, everything, it's managed by the cloud. Great. For you as a network engineer, you have to put like the operating system to install the operating system, Windows, Linux, whatever. Okay, to do like the middleware and runtime environment between your data and operating system and the application. So in the upper portion here, this is you as a network engineer, you will take care fully about it. In the second part, in the platform as a service, the PaaS, if you can see, the network, server, storage, virtualization, operating system, middleware, and runtime environment, the cloud provider will take care of it. You, as a network engineer, will take care about the application that you are using, the data. This is managed by you. Like, what is application? Maybe like you have an ERP system you want to install. Okay, so you will just install. You will find your VM machine with the operating system installed, and just you will install your application and you will manage your application with the data. There is something like more commonly used for some scenarios called SaaS, software as a service. Everything is maintained by the cloud provider. You, as a network engineer, you don't care about anything of the management for that. You will use it. An example for that, or good example for that, like Netflix. Netflix is completely SaaS. The application and everything is running on the cloud. Okay, we are only like using only Netflix. uh, Google, Google OneDrive on the Google, Zoom, Microsoft Teams, all these considered as software as a service. Great. So, what are the cloud service provider in the market? There are many actually. The reason for that is AWS, this is for Amazon, Azure for Microsoft, Google Cloud, and Huawei Cloud. These are like one of the biggest cloud provider company that you can uh, subscribe with them and start your cloud services with them. But uh, what I want to explain here or to highlight on it, really, if you learn one of these provider, you will understand about 90% of the cloud and how the cloud service, because they are similar up to 90%. The 10% is different, like each cloud provider, what is the unique services he's using, how the GUI of the platform he's consist with, uh, the terminologies for that. For example, the virtual machine in the Huawei cloud is called ECS, and in many other. For example, in AWS it's called EC2. So that's just terminology. They are all the same. How the system are working, how the architecture are working, they are completely same. Great. So let's talk about and come to our main topic here, the cloud computing services. There are three main major services in any cloud computing provider or cloud in the cloud computing in general. There are compute, network, and storage. Compute is when you are creating your virtual machine. It has two types, virtualization and container. Network, any infrastructure, need for a network, need for switches, need for router, need for gateway, NAT, many things. So obviously in the cloud, when you are creating your servers or VMs or your instances, let's say, so you have to make your subnets, your networks, you have to connect them to each other. You have to make them available for accessing through the internet if it's required. So all these needs for networking. That's why I'm saying you have to be like very good knowledge and strong in networking, and also on servers and and machines and storage and how to do that. Great. The third service that Can Cloud giving to us is storage. Storage, as we know, like storage has three main categories: is block storage, file storage, and object storage. We'll come to each part in a while. So, what is virtualization? We are calling now. We are talking about compute services. We said that we have two things here: virtualization and container. So let's talk about virtualization. We are doing like a virtualization. It's referred to process of creating multiple VMs that share the hardware resources of physical server. So what is the hardware resources? It can like share the CPU, it can share the RAM, the hard disk, the GPU, the graphical process unit. You can actually in the virtualization, you can share resources or virtualize resources and customize it as a small server or small entity as you want. Great. A VM consists of disk files and description files, which are encapsulated in the same folder. Multiple VMs running on the server are separated and encapsulated in multiple folders and manually isolated, and mutually isolated, sorry. These folders can be stored in the file system provided by the underlying storage. Therefore, multiple VMs can be run or stored as shared medium. The key concept of virtualization involves separating software from hardware by converting physical devices into logical folders and files. We can say virtualization is management of the physical resources and represent the VM with the specific file. To sum up this, in the virtualization, where when you are doing like a virtual machine and you're doing your setup and you installed all your runtime softwares and application that you have and you make it properly working and as you want, you can take a image or a snapshot of this VM and keep it aside. Go to any like virtual platform and just import it, so you can get the same result or the same machine with the application that you did, because at the end it is stored as a files in this, inside the folders, so it will be a file. It's heavy, yes, it's heavy, and the importing will take time, yes, it will take time, and we will see like what is the difference between it and how they solve it with the container. But actually this is a brilliant idea for that. Great. So the feature of VMs is giving me like partitioning. Multiple VMs can run on physical server, which means that the virtualization layer can allocate resources of the physical server to multiple VMs. So when I'm doing a VMs, they are completely isolated together. Unless I want them to communicate with each other, yes. Uh, so isolation here, if one VM on a server is faulty or infected by virus, the other VM can still run properly. Also, if we have multiple VMs on a server with a different guest client, then no one can access any other unless I want. Okay, unless I put the rules for them to be communicating each other. But here, what is the concept is? Imagine that your physical server running only operating system like Windows Server, and you have all these features: Active Directory, domain controller, DNS server, whatever. So imagine that this is your server infected by virus or worms or like malicious software, malware. So all the entire, because you have only one physical server, so the entire is infected. But with the VM, if you are doing like this is an Active Directory virtual machine, this is a DNS virtual machine, this is SQL Server virtual machine. So let's say that the Active Directories got infected. The rest of the servers, they are working normally, so they are not infected for that. Encapsulation: VMs stored on virtual systems as files, so you can migrate VM by cutting, copying, and pasting files. It's very easy, yes, heavy, yes, but yes, you can do that. And dependencies: after being migrated to another physical server, a VM can properly run without any modification on the server because VMO is decoupled from physical hardware. And this is actually true because when I'm copying and importing it, so automatically the new VM that I'm getting, it will take the same resources, and I mean by resources, in the same CPU amount, in the same RAM, the same hard disk capacity, okay, and the same application that I installed without any modifying, without any feeling of there is something changed. Nothing will be changed. So the importance of virtualization concept. If we can see like the physical server, here is the physical server here. We'll install the operating system, and on the top of the operating system, our application. The concept is different in the virtual machine because there is a physical machine, yes, and there is a hypervisor layer. And this hypervisor layer, in the top it, you can create a guest machine, many guest machine as you want. So in the guest machine, you can put operating system and your application. Another guest machine, you can put Linux, for example, operating system. The first one is Windows, this is Linux, and your application. So you are sharing resources from the main physical machine. Computing resources, of course, when we are doing like a compute resources for that, we are sharing memory, GPU, CPU, as we said. So compute services. So what is the compute services? Now again, I will remind you, we have three main things. We have compute services, network services, and storage services. We are still in the compute services. In the cloud, we have Elastic Cloud Server, ECS called. It's a VM machine. And we have something called auto-scaling. The auto-scaling, it's increase or decrease the number of ECS dynamically. For example, the auto-scaling, all of course service providers using this is same concept. Uh, Imagine that you want to you have a website. This website is a trading website that you are selling some goods on it. So you want to do like a massive deal for that. Let's say iPhone 16. It's around $2,000. This is the original price for it. So you want to do like a 50% discount of that, and you did your marketing campaign already. So, and you said that within 4 hours, like from 6 p.m., let's say to 10 or 11 p.m., the promotion will be there or the offer will be there. You will not be able to predict how much the people or traffic they can visit your website. You have this website is located on a server. This server was like capacity. This capacity, let's say it's 1 terabyte hard disk, 8 GB RAM, 4 core CPU, and you are paying a less amount on it. But how you can predict it? If we asked anyone, no one will can give you like a proper design for the server that we need. So here is the beauty of the cloud. Auto scaling, you can put your rules in the auto scaling. You will say if the number, for example, of RAM is exceeded the 60%, add for me 2 GB RAM. And it's also, this is the threshold for you, is a 60% or 70%. So within this threshold, then the auto scaling will start working. The same of like the processing wise. Okay, you can put that thresholding, and within this thresholding, maybe it will replicate your VM to 2 or 3 VM. And of course, it will be something like in the middle called ELB, Elastic Load Balancer. This ELB to share the traffic between your machines. For example, if you're auto scaling, it create dynamically for you 4 servers or 4 VM machines. So these 4 VM machines, the traffic, I want it to be shared like, for example, something called in the networking round robin. Okay, one traffic will be in the first server, another will be in the second, the third the traffic will be in the third, the fourth, and continue the cycle for that. So by that I can load sharing here, and I have like 4 virtual machines for that. The auto scaling is my trigger. So if the traffic came down, so the machine will be deleted one by one, but the original will stay. The original will not be deleted at all. So here, how I can pay for the cloud computing, I can pay per my use. So I use them within these 4 hours or 5 hours. Okay, I use these like services. They will give me, yes, okay, you can pay this amount for that. And actually, it's something brilliant because the traffic came to me during this promotion. But normally, yes, my one server can handle that. And the image management service IMS is to provide operating system image backup for the ECS that I have. ECS, it means the VMs. Okay, so this is like what I explain right now. So the second thing of the computing in the container. Actually, the concept of the container is it's container called first of all is a light portable technology. The VM, it's virtualize your hardware, but the container is virtualize your software. Okay, the operating system maybe the software itself, and it's a very lightweight. For example, if I get a snapshot from the VMware or the virtual machine, it will be maybe like in gigabyte or terabyte. It depends on the machine size. But with the container, it's the size of the file is very very minimal and light. That's why it's calling like lightweight portable technology. So it's a standard unit that packages an application code and all its dependencies, enabling the application to run across different computing environments. Simply put, containers are like standardized boxes that can hold different types of things and be put into different cabinets. It's great. It's actually now the trend actually in the virtualization. So container can package software into standardized unit for development, migration, and deployment. Isolate compute, storage, network, and other resources, start, stop, deploy, and migrate application agilely and instantly. Allow also developers to focus on R&D, research and development, and operation and maintenance engineers to focus on system maintenance. So difference between containers and VMs. Here, if you can see that the container architecture is you having the infrastructure and you have the host operating system, and the container will come on the top of the operating system. You can create as or virtualize as much as application as you want. But in the virtualization architecture, the infrastructure you have, the hypervisor layer, you have it, and you will create to start the VM. And inside the VM, you will be having the operating system and the application. That's why it's heavier than the container. So the container, when you copy the file, you will copy the file as a binary code. That's why the file is very light. So here, if I want to compare a quick comparison between the containers and VM. So the container speed of processing is seconds. The VM is minutes to boot up and to work. The virtualization type is operating system virtualization. That one is hardware. We are doing the virtualization in the hardware level. Operating system dependencies. All containers share the host operating system. But in the VM, each VM runs its own guest operating system. So in the container, I'll be having the operating system and I will start virtualize this application. I'll do the virtual of the application. If you can see that they are sharing the operating system itself. But in the VM, they are sharing the physical machine, and there is hypervisor, the virtualization layer that they have, and you will be having the completely isolated the VM for that. So isolation strategy is using hypervisor, but in the VM it's using something called cgroup. Image size, when you are taking a backup, if you want to use this container somewhere else or the VM somewhere else, here is telling you that the image size is between kilobytes to megabytes. But for the VM, it can be like gigabytes to terabytes. And it's obvious that it's heavier than that. Virtualization performance on pair with physical servers, and the VM is limited. Per machine capacity, over 1,000 containers for each physical machine. But the VM is dozens of VM machines. So if you want to think about the cloud computing services for the container, we'll be having is CCE, Cloud Container Engine, Cloud Container Instance, and Software Repository for Container. So if you can see that I have the Cloud Container Engine, it's the machine that I have and or the container that I have. Inside it, there is node 1, and inside the node is pod with container and as much as pod I need. And there is like something called cloud container instances. This is the container that I can like run it immediately with that. So the second thing of the compute services is the network. So let's talk about what is network component that we have in our infrastructure. We'll be having layer 2 switches, we'll be having layer 3 switches, we'll be having also routers, firewalls. So all these like consist in our network. So if this consists also in the cloud computing, of course, yes, but in a different concept, but it is the same. So, and even like for the frames to be here and there, like the broadcast and unicast communications, the router, it will be like my gateway to get me to the internet and many others. So it's telling you that if you have your you have your network infrastructure and you uh, subnet it and you do like segregate it with the VLANs. So like you'll be having the switches between the switch, it will be trunk, and this trunk will be like allowing for the inter VLAN to communicate to each other or inter VLAN routing, etc. Let's talk about like conventional network devices, router layer 3, layer 2 network interface card. So in a very quick, I will give you like layer 2 switch is a switch that working in layer 2 in OSI model. It's understanding only MAC addresses and is responsible to data delivery from hub to hub. Layer 3 switch is working on layer 3 in OSI model. It understanding IP addresses. So also it's considered is responsible for data delivery from end to end. Router is our working in layer 3 in OSI model. It will be most of the cases our gateway to get us to the internet. It's responsible also for data delivery from end to end. Is there a difference between router and layer 3 switch? Yes. Uh, Layer 3 switch cannot act as a router fully because as we know that a switch is a single communication technology, but the router is multi-communication or mixed communication technology that it can working with Ethernet and WAN and many things. But with the switch, if I have like Ethernet switch, so it's Ethernet switch. If I have a WAN switch, it will be a WAN switch. Also, layer 3 switch cannot support one technology, cannot support NAT, cannot support like many things. But they invented it to act for the SVIs, intervenal routing, and many like access control policy to just make the router relaxing for that. NIC network interface card, any PC or any server, any device should have like network interface card. It will be have either wired or wireless. So it's working in uh, actually it's mixed between layer 1 and layer 2 in OSI model. Uh, But yes, we can consider it in layer 2 because it's understanding like MAC address. Okay, so this is actually the NIC, as we all know what is the NIC, and we connected the NIC to the switch, of course. So, what is the concept of the virtual networks? Virtual networks, it started from VLANs. The VLAN is layer 2 technology that it allow us to segregate our networks to make it more enhanced in the networks. It's increased the broadcast, okay, but it's again limiting it, and it has kind of security because maybe this VLAN, I don't want it to talk to another VLAN, so it will be isolated from each other unless I enable it through the inter-VLAN routing. So here, if I have a guest machine and I have like a physical switch, so in the virtualization, I can do like something, a concept of virtual switches. So I can do the virtual switch to connect my virtual machine and put them in the different subnets. So the concept of that is how we can like communicate with the virtual machine to each other or segregate them in each other. So everything in the virtualization is taking from the original uh, physical resources, like in here it's taken from the original network interface card. So if we come to the virtualization, the type of the network interface card in the virtualization, it has bridge mode and NAT mode, and there is also one third one called custom mode. So bridge mode, it means that you are taking the same subnets of your network from the physical network interface card. The NAT mode is no, I want to use a different subnet rather than the original subnet in the physical host. So it's called like NAT mode. Custom mode, if I want to custom my network interface card with like a special type of uh, of the virtual machine and do like my own subnetting also for that. So also there is a concept of virtual switch. As we have the physical switch, we can have like a virtual switch, and this virtual switch we can map with the virtual machines. So the common virtual switches model that includes OVS and EVS, Open Virtual Switch and Enhanced Virtual Switch. So in the compute services for the network, we'll be having three things. Virtual Private Cloud, VPC. Virtual Cloud is the virtual switch. You can understand it like that. Okay. NAT gateway, yes, the network address translation. Anyone knows like the NAT, the type of the NAT that we have. Mostly we are using something called NAT overloading or PAT, port address translation, that all the private IP addresses is going to the internet by the one public IP address, and this is the most commonly used for that. So yes, you have it in the cloud, and you have something called elastic IP. Elastic IP is the static IP address, public IP address, real IP address that you can give it to your gateway for your VMs or ECS, if we are talking in cloud computing terminology, of your ECS to going to the internet. And also, this is yes, you can rent it per device. The third compute services that we have is storage services. As we can know that the storage that we have is block storage, file storage, object storage. So this is a normal actually infrastructure that we have. So block storage maps the entire raw disk space to server. For example, if you have like 5 disks, great, and this disk is we can do something called RAID. Okay, so we can do like something called RAID 5 or RAID 6. So the hard disk is directly attached to the server, and you are doing this also your virtualization based on the hard disk itself. So it's very fast in speed, and when you are doing like with backupping and all this stuff. So, but here, of course, firstly you have to format them all, and after that you can do a logical group. This is what's called RAIDs for that. So, block storage is ideal for most data storage scenarios. Like when you are storing data, yes, because they are very fast and attached directly. So, file storage, when you are working on file storage, it's really the same of when you are saying sharing files that you are in your enterprises and you have your server, and this server you have your shared server over there, and your employees is using the shared file for that. So this is the same concept. This is called file storage. So file storage is like a shell folder in a file system Users can directly store data on the file storage device over file system. Access protocols such as NFS and CIFS. File storage is widely used in scenarios such as data backup and archiving, image and video data storage, and file sharing. The most actually scenarios they are using in the file sharing. And of course, the file sharing could be like network, SAN, and storage area network or NAS. So finally, the object storage. Object storage leverages both a block storage and file storage. It offers fast direct disk access and distributed file sharing. Generally, object storage outperforms file storage. So the application scenario of object storage is widely used in scenarios such as data backup, image video data storage, and website hosting and ERP system actually because object storage, object storage is storing the files and containing of metadata and it's doing a distributed storage for that. So when you are claiming for this storage, so it will be like fast and it don't care about the data type for that. Maybe it will be like a structured data, unstructured data, and semi-structured data. It does not care about that. So here in the object storage, it has large scale data management capability, which is biggest advantage over file storage. File storage uses a hierarchical structure to manage all files and directories. If there are too many files or directories stored, the search performance will be greatly reduced. Object storage provides a flat structure where all objects are stored at the same logical layer. This keeps the objects search speed almost unchanged even if there are tens or billions of objects. However, object storage uses application level APIs instead of system level APIs. Traditional applications need to be redeveloped when being migrated to object storage system, which makes the popularization of object storage difficult. Object storage is applicable to scenarios such as big data, IoT, backup and archive. It provides EB level capacity and has the highest data durability among the three types of storage. Why that? And you can find if you like study more in the compute services and especially the big data, you'll find that the cloud provider using something called Hadoop. Hadoop actually is an open source that's the concept of it is working on the object storage. You'll be having like multiple machines and this and all your file will be like the file will be stored in different machine each file and the retrieve for data because it's working on the metadata for that it will be retrieving from that. So the cloud storage services, you have three types. Elastic volume service. The elastic volume service it is the same of block storage that we studied before. Scalable file service, SFS, it is the same of file sharing. Object storage service, OBS, it is the object storage. They are three in the cloud working in the same concept of the traditional. Here, what we explain here in the traditional storage for that. Uh, we came to end of this video. First of all, I would like to thank Tidra, the Virtual Academy, of giving me this opportunity to explain about the cloud computing services. And I hope you will get like benefit of this video. And if you have any questions, you can write it like in the comments and wait actually for more explaining of more topics. Thank you very much and wish you to see you soon.